Hi, today we're talking about bash shell scripting, which I'm going to do in a few different parts because it's a really wide topic. So in this first part, we're going to look at what a shell script is, so look at some of which scripts already exist, what the shell variables and user-created variables are. We'll create and run simple scripts. We'll see how we can pass arguments or parameters to the script. We will also be using echo command, understand what a return value is, and look at testing file status. So lots to cover. And we will first create very simple scripts. So shell scripting, when we're writing a shell script, we're really using the built-in programming language of the shell, the Linux shell, to put a bunch of commands together. So far we've just put commands one at a time. And we see the result, and that's how we've been functioning. So we say ls, we hit enter, and it gives us the result. But when we're working, we're going to have a need to put a bunch of commands together. So not just do one thing, but do a bunch of things together. And not only that, we'll have to do them maybe based on some conditions, based on if something ran in a particular way or not. So all of that is possible if we create a little program, which is a script. And that's what we're going to do in this part of the course. There's built-in scripts that are already there. So, for example, there are some system-wide scripts that exist which run every time that we log in. If we do an ls on the etc directory, which you know from the first couple of lessons was one of the system directories that exists right under the root. So here there's a file called profile, and that's created by the root, as you can see. And we can't change it because you can see it's just read-only for us. The root user can make a change, but not us. So this is run for every person when they log in. And it has a bunch of things that it sets up. So it sets up the environment for the user. Now, in our own home directory, we're going, so if I just do cd, so if I look, I'm in my home directory, home/praveen.matera. Here you will find there are some files which deal with bash profiles. So ls-la and anything beginning with bash. So you see things like bash history, bash logout, bash profile, bash rc. So those are some of the scripts which are already there, and some of them run automatically. So bash_profile will run automatically and set up more things within me as a user, and it'll do the same for all of you. Bash rc may not always run on its own, but we can make it run by simply typing its full name. So notice these are beginning with a dot, which means these are special types of hidden files, but we can still see them because when we say ls-la, we can still see those. We can also see the environment variables, which means the shell has set up some built-in variables, and these are usually all uppercase, and they will hold information about the environment that you're functioning in. So if I type env, and I hit enter, you'll see a bunch of things here. So these uppercase things that you're seeing on the left is the name of the system variable. So for example, log name is all uppercase variable that the system holds to keep the value of the person that's logged in. Similarly, uppercase home, it's holding the value of my home directory. How do I see if I want to retrieve that value at some point? In a script or just on the command line, I can use echo. Echo will show you the result on the screen. So if I say echo, the actual variable is home, but in order to see the content of that variable, I have to put a $sign in front of that variable. So when I say echo home, I'm telling the system to go in, show me what's being held inside the variable called home. And as you can see, it holds my home directory. Similarly, if I was to say echo and I said $log name, I'm going to see the content of the variable log name, and it shows that to me. So these are system variables, which means information about the platform you're on, about the system, about your logged in home directory, and so on, is being held in those variables by the Linux operating system. And you can also create user variables. In other words, they don't exist, but you can create them. For example, if I say course equals ULI 101, I have created a variable called course, and I've deposited this value into that variable. So if I say echo $course, it's going to show me the value that I've put inside. Now, variable names can have uppercase, they can have numbers, they can have underscore, all of those are okay. But what you have to remember is you cannot begin the variable name with a number. So I cannot say 1, 2, 3 and then course. That's going to be wrong. I can begin with underscore, no problem. That's okay. So beginning with underscore is okay, beginning with upper or lowercase letters is okay, but beginning with numbers is not okay. Generally, we don't need to use double quotes, but if we were putting let's say if I was saying course equals ULI and a 101, then I'd have to put quotes because I have a space here. It's going to otherwise consider this as separate from this. So if you have a value in which you're going to also have spaces, then put quotations around that. So now if I echo $course, I'm going to see that it kind of keeps the space there as well. All right, let's start by making a simple script and understanding what scripting is about. So let's see where I am. I'm in my directory called new scripts within my home directory. So let's create a basic script. To do that, you can use any editor. We're going to use VI and give the name, I'm going to call it S0-list. Now, I'm giving it .sh, but as an extension, that's only for my use. So when I look at a file name and I see .sh, I know that it's a bash shell. Linux does not need any extension to find out what kind of file it is, but .sh is one of the common extensions used when you're working. All right, so when I hit enter, I'm entering VI. I'm just going to go escape I to enter the insert mode. And the first line that you're going to put to make a bash shell script, the recommendation is to always put the bash declaration, also called the shebang line. So hashtag followed by the exclamation mark, and then the path of where the bash shell exists, which is generally going to be in the bin bash. If you do not put this script will still work in my current environment, but when you're working, it's a good idea to always put this, because you don't know, once you create a shell script, you don't know which environment it's going to run in. Another person may have a different default shell instead of bash. They may have corn shell or C shell. So when they run the script you've created in the bash shell, they may get some errors. So to avoid that, if you always put this shebang line or the bash declaration line at the top, then this, as soon as the script is run, the system will force it to open a new instance of the bash shell, and the entire script will run in the bash shell regardless of which default shell is in that environment. That's why it's important to put this line always. So I'm going to recommend that you always put this as the first line. All right. Any other time when you want to do a comment, you can do a hashtag, and this would be your comment line. So in this case, I can say that this script will list all files in my current directory. So it's a very simple script just to show you how it's done. So anytime I have the hashtag in front, that's a comment line, therefore it'll be ignored. The bash shell scripting is an interpreted language. So it'll do the first line, then the next, and keep interpreting as it goes. So when it comes across the hashtag, it will ignore that line. That's why this serves as a comment. Now, after you've declared the bash shell, put some comment, then you're going to put the commands that you want to put together in a file. So let's just put a very simple command of ls-l, and that's all I'm going to do here, just to show you how to create a script. So if this was the command and I'm done, I'm going to escape colon to come down, W and Q to write and quit, and now I have a script called s0-list.sh. If I look at the permissions of this, you can see that it's created with the default permissions, as you know, based on my UMask, as we learned in one of the previous lessons. So it does not have what's called an executable permission here for me, the user. So if I try to run it, to run a script, you would just go / and the name of that script. Yes. So it says I don't have the permission to do that. And that's because I need an executable permission. So as soon as you create a script, the first thing you have to do is to make it executable. So I'm going to do a change mod. And for myself, I'm going to add the executable permission. And now when I look at the ls command, I can see that I have the executable permission. So now I'm good to go, and I can run this. So / and the name of the file, and there we go. It's done its job of listing all the files that are there. So why did I put two things? Always remember to make it executable, and secondly, why did I put / here? Again, that's one of those things where it's good practice to do that, and the reason is because this will force the system to look in your current directory. That's what the dot is, because sometimes the current directory may not be listed in your default path, and it's even though the file exists in your directory, it won't find it. So if you say / it forces the system to look in the dot, which is the current directory, and therefore it'll always find it when you create it. So I would suggest always running it in this fashion for that reason. All right, so this is a very simple script that we've created. So we saw that there's 3 parts to that script. Let me just cat that again, one moment. So the first part was the shebang, or the bin bash declaration. Second was any comment you want to put, beginning with the hashtag, followed by the actual one or more commands, which are going to run from top to bottom. So once you understand those are the 3 parts needed in a script, let's go ahead and start building scripts that are a little more involved. Before we do that, I want to talk about what's called arguments or parameters. So sometimes we want to pass some value into a script, and that's where the positional parameters, also called arguments, also called just parameters, those are passed in. So to access the value in those parameters, we have to put a $ in front of a 1, 2, or 3, and so on. So $0 would give the name of the script. $1, 2, 3, etc. would refer to the first, second, third argument. We can go all the way up to 9. We can do $, which captures all the arguments, or $@, which also captures all the arguments. And $pound, or $hash, gives you the number of arguments you've entered. So this will all make sense as we use it. So let us go ahead and start using and creating a script. So in order to save time during the tutorial, I've created the blank templates for each of the scripts we are going to talk about. And we will go in there. That'll just save us a little bit of time. These are already made executable, each one of them, and they already have the first line, the shebang, and the comment telling you what that script should be doing. All right, so I'm going to go into VI, and I'm going to go into this one. Notice that I don't type the entire name because I can use I can start typing and then press my tab key, which auto completes that particular name. So that's a handy trick that you can use as well. All right, so S1. So we already have the shebang or the bin bash declaration at the top. I already have a comment that says this in the script. I'm going to display the top 3 lines in what's called file 1. All right, so from your commands that you've learned already, you know that we can use the head command. And if we are only wanting to show the first 3 lines, then I'm going to say -3, and then I need to give it what file name it should look in. And this will satisfy and give you the solution you're looking for. So this will display the first 3 lines or the top 3 lines inside file 1. So I'm going to save this. It's already executable, so I'm just going to run it. So again, /S1, and I'm tabbing it over. And you notice that I'm getting 3 lines here from file 1. If I cat the whole file, I have 8 lines in that file. I just put line numbers as a part of the data just so it's easy for you to visualize. So we just created a script and it ran successfully. Now, in this case, the only thing anytime it will do is it'll always only display the 3 lines, and those lines will always be displayed only from file 1. So this is where passing a value would make more sense and would make the script more flexible, because I can pass a number and say I want to display 5 lines or 10 lines or 2 lines. So that's where we will pass a parameter to this next script. So let me go into VI. I'm going to go into the next script, which is saying that the user needs to pass a number to indicate how many number of lines you want to display from the file. So again, in order to do that, we're going to use the head command. But instead of using -3 here, I'm going to use $1. So I still need to put the dash, but $1 means the first argument the user is going to pass will be held in this as a variable, and that's how many lines will get displayed. And I'm still putting the file 1 here. So notice what happens now. Let's save it. All right, so let me run that. If I run it without anything, it's not going to know how many lines it needs to show. So I'm going to pass it, let's say 3 lines, and it shows me 3 lines. If I now run it again and I pass it 5 lines, it's now showing me 5 lines. If I run it showing and ask it to show 6 or 7 lines, it's going to show 7 lines. So that's the beauty of using a number that you're passing as opposed to having it hard-coded inside. So because we had $1 here, when I passed, let's say 5, this got replaced by the number 5, so this would have been read by the system as head -5 file 1 or head -5 file 1, which is what's making it display the 5 lines. Wouldn't it be nice if I could also replace this with an argument so that I can also pass the file name? And that way I can not only say how many lines I want to display, but also which file I want to look at, right? Okay, so if I look here, I have file 1 and I have file 2. So let's see what's file 2. It's just another file. I have file 1, which we just looked at. So these are 2 different files. So let us change the script in a way that we can not only tell how many lines it should show, but which file it should show from. So I'm going to VI the next one. So here again we already have the shebang, And the comment says we have to pass 2 arguments. The first has to be number of lines, second has to be file name. So again, we're going to use the same head command, and we're going to say dash and then pick up the number from the first argument. But now instead of giving file1 as the name, I'm going to use $2 because there are 2 arguments. So the first is always held in $1, second is always held in $2. If there was third argument, that would be $3 that you could use if you wanted to. So this is my entire head command. If I now save this and we run it. So I'm running the script, but I'm going to pass, say, 4 to say I want 4 lines, and the file I want to pass is file1. So see how I'm passing 2 arguments, 4 and file name. So 4 will get replaced here, so this will read -4 or -4. File name will get replaced here. So this ends up showing 4 lines from file1. And I could also run it again. Now instead of 4 lines, I can say I want 3 lines, and instead of file1, I can say I want file2. So now it's going to the other file and picking the first 3 lines and showing them to me. So you see how we can make it really flexible by passing values into the script. That's the beauty of the positional parameters, or the arguments that you can pass. Now the next concept I want to talk about is the concept of a return value. So every time when we do any command, it actually passes a return value. So when we do an ls, it says, it looks at that command, runs it, and if it's successful, it makes it a return value of 0. If it's not successful, you get a return value that's not 0. It can be any non-zero value. However, how do we check what value it has returned? We can echo it. We can echo $? And that'll show you what the return value is. So let's take a look here. So let's say I just do an ls command. Now we did the ls command, it was successful. So as far as Linux is concerned, the return value it would have sent would be 0. So how do I see that? I echo $? And I see a 0. Right here. That means my previous command was successful. If I say ls file1, again, it found the file1, showed it to me. So this whole command was successful. So my echo $? is 0. Notice what happens if I say file 100. Now I don't have any file 100, right? So this is giving me an error message. What does that mean? It means my command ls file 100 was not successful. So now if I echo $? I do not get a 0. I get a 1, a 2. It can be any non-zero value which the system assigns to it. So by capturing and looking at $? We can see what the success or failure of the previous command was. The important thing here is to understand that this value is only relevant for the command that happened immediately before. So this does not pertain to any previous command, or the command before, or the command before. It only pertains to what happened immediately before this. All right? Okay, so let's see. We'll be actually using this within our script in a moment. But I also want to show you file status and what that means. So when you we have so many different files, and in a script we may want to check whether that particular name that's been passed, maybe is it a directory or file? Is it readable? Is it executable? So it's very powerful that within Linux we can actually check any of those things to see whether something is a file or directory, whether it has a certain type of permission or not, whether it exists or not, and then build the script based on the result we get. So if we want to check if something is a directory, we can use -d within square brackets like that. To check if something is a file is -f. -e we can use to see if it's something a file or a directory. And we can check R, W, X for read, write, or execute permission for the user, and S for size. So let's look at that in action. So I have D1 as one of the directories, so I can say D1. So what I'm telling Linux is D1 a directory? That's what I'm saying. And now if I echo $? It's giving me a 0, which means, yep, that's a directory. Notice that if I say the same thing, and instead of D1, if I had said file1, now we know that file1 is a file, not a directory. So at the end of this, if I do echo $? I do not get a 0. I get a non-zero value, which means this command is not successful. I asked it to check if a certain thing is a directory, and it's not. So I do not get a 0 here. So that's how you end up using the $? So let's create a script using this. So I'm gonna vis4, and here we want a file name to be passed to the script as a runtime parameter or an argument. We're going to check if that file exists. And if it exists, we're going to display a message saying so. All right, so how do we check, first of all, if it exists? We're going to use the square bracket, -e for exists, which can be used to check either directory or file. And instead of giving the name of the file here, because the file is being passed, we're going to use $1, because $1 is where it'll be stored when it's passed, right? And we close the square bracket. So when it's going to check this, it's going to return either 0 or a non-zero value. So our next statement is that we're going to build an if statement here. So because we need to check whether this, what kind of a return value it has. Actually, you know what? I'm just going to echo $? And we're going to close it so that we can see what it shows. So I'm just going to run this, and I'm going to pass a file name. So /, I'm going to run this, and I'm going to pass it file1. And it shows me 0 because it ran this, it checked file1 because file1 was held in $1. So it checked it, and then it echoed $? And it showed a 0. When I run it again, and I'm going to pass file100, which does not exist, it's giving me a 1. So it took file100. This statement became check -e file100. That was not existent, so this was a failure. So $? Contains something that's not a 0, and it showed me what it contains, and it has a 1. Let's vis4 again to complete the script. So instead of just echoing this, we want to display a message to say that it exists. In other words, we want to have an if statement check this. So let's replace that. So the if statement goes like this. You have an if, you have a condition that it's going to check. If that condition is true, then it's going to do some commands. So I'm going to, echo a statement, for example, of some sort. And when it's done, we have to close the if statement. So this is the construct of an if statement. If, condition, then do a bunch of commands, and close the if statement. To close the if statement is the reverse of if. So fi, instead of if, you close it with fi. So let's build that up. So the condition we're going to check. Now we've already checked whether the file exists or not. So the condition we have to put here is we're going to check the success or failure of this command. That's how we know. How do we check success or failure? We're going to have to check the value that's sitting inside $? And if that is a 0 means it exists. So how do we check if it's a 0? Well, we have to use an operator. The operator for checking a number is EQ. There's EQ for equal, GT for greater than, LT for less than, and so on. So this is going to ask whether the value stored inside $? is equal to 0. And we close our square bracket. And if this is true, then we're going to do this set of commands. So if it's true, we're going to echo a message that says their file exists. So instead of giving, because we don't know what name a user has passed in, so we must use $1 again so that we can give the right file name back to the user in the message. So we're going to say this does exist. All right, and that's all we're doing. We're then closing our if statement. So let's see what happens now. So we're going to run it again, and we're passing file 100. So let's actually do it with the file which does exist. So now it says file 1 does exist because file 1 was checked here and it returned 0 because it was successful. So this statement became true because this would contain a 0, and the question here is 0 equals 0. Yeah, true. So then it did this statement, which is echo $1, which had file 1 in it, does exist. If we run the same thing and we pass it file 100, now it will not give any result. Why? Because this is now checking if file 100 exists. The result is a non-zero value inside $? So when we check, is $? Equal to 0? It's going to say, no, it's not. It's only if it's true that it does these commands. Otherwise, if it's not true, if the condition is not true, then it goes to the end of the if statement and there's nothing else after that. So it didn't show us anything for that reason. If we go back here, and I'm just going to echo, this is the last line, just so that if it comes here, it will actually, instead of showing nothing, it will actually show us this. So let's run it again, and now it actually shows us this. Why? Because file 100 makes this statement false. So this has does not have a 0 value, so it does not do this. It comes to the end of the if statement, and then it'll just continue on. So because there is an echo statement here to show the last line, that's what it's showing you. If I run it with file 1, we only see the message which says this does exist, but then when it finishes the if statement, but it doesn't stop there. Nothing is making it stop. It's going to continue. So it continues on and also shows you this line. So it shows both these lines when it's true in this case. All right. So that kind of starts to give you an idea of how a script can be created and how it works. In the next video, we're going to continue with some more aspects of building other aspects of the script. Okay, hopefully it's starting to show you that it can be really powerful because we can check so many things automatically. All right, that's it for this video. See you in the next one.